All right, everybody, welcome back. Ready for another deep dive?
Always ready.
Awesome. So, today we're going to be tackling something pretty massive, literally.
Sounds intriguing.
Yeah, it really is. It's called the Deep Underground Neutrino Experiment. DEE for short. You heard of it?
Oh, yeah. I've definitely come across it in my readings. Sounds like a pretty ambitious project, sending neutrinos on like a 1,000-kilometer journey through the Earth.
It's crazy, 1,300 kilometers to be exact.
Yeah.
From Illinois all the way to South Dakota.
That's wild.
I know, to study these little tiny particles, these neutrinos. But the thing is, like, why? Why go through all this trouble?
Well, neutrinos are incredibly fascinating particles. They're these tiny ghosts that barely interact with anything.
Ghosts. I love that. Okay, so tell me more about these neutrinos.
So imagine this. Trillions of neutrinos are passing through you right now.
No way.
Yeah, every second. And you would never even notice.
That's crazy.
It is. They're almost massless, they're electrically neutral, and they just zip through matter like it's not even there.
Oh, so how do you even study something like that? I mean, if it's basically invisible and doesn't interact with anything.
That's the challenge, and that's why DUNE is such a huge undertaking. You need incredibly sensitive detectors buried deep underground to shield them from all the other cosmic noise.
Makes sense. So they can pick up those rare instances where a neutrino actually bumps into something.
Exactly.
All right, so we've got these ghost particles zipping through us, and scientists built this massive underground experiment to try and catch them. But the real mind blower is that some scientists think this experiment could actually help explain why the universe even exists.
It's definitely a big claim, but there is some compelling physics behind it.
Okay, break it down for me. How do neutrinos connect to, like, the ultimate question of existence?
Well, it all comes down to this thing called the matter-antimatter asymmetry problem.
Antimatter. Sounds like something straight out of Star Trek.
Right. But it's a real thing. So basically, when the Big Bang happened, matter and antimatter should have been created in equal amounts.
Makes sense. Equal and opposite.
Exactly. But here's the problem. Matter and antimatter, when they meet, they annihilate each other. Boof. Pure energy.
So if they were created in equal amounts, shouldn't the universe have just been like this big burst of energy, nothing left over?
Precisely. But, well, look around. We obviously live in a universe full of matter. Stars, planets, us. So the question is, where did all the antimatter go? And why is there something rather than nothing?
Wow. Okay. It's kind of blowing my mind that just existing is a mystery. But I still don't see how D and E fits into all this.
So one of the leading theories about this matter-antimatter imbalance is this idea of CP violation. CP stands for charge conjugation and parity. It's a very subtle difference in the way matter and antimatter particles behave.
Okay, I'm going to need an analogy here.
Sure, imagine two clocks, one made of matter, the other antimatter. They look identical, but if CP violation is real, one of those clocks might run slightly faster than the other.
Okay, so that difference in how they behave, even though they seem the same, that's CP violation.
You got it. And DUNE is designed to look for CP violations specifically in neutrinos.
So, if they find it, what then? Does that solve the whole matter-antimatter mystery?
Well, it would be a huge clue. If neutrinos violate CP symmetry, it suggests that a similar process could have happened on a much grander scale in the early universe.
Meaning more matter survived because it behaved just slightly differently than antimatter.
Exactly.
Wow, that's incredible. So we could potentially see the very reason why we exist playing out in this experiment.
It's definitely a possibility, but it's important to remember that even if we find CP violation in neutrinos, it might not be the whole story. Some scientists are skeptical.
Oh, really? Why is that?
Well, there are a couple things. One is the scale. The amount of CP violation we might observe in neutrinos, even if it exists, may not be enough to account for the huge matter-antimatter imbalance we see in the universe.
So it might be a piece of the puzzle, but not the whole thing.
Right. And then there's the whole issue of theoretical particle.
Oh boy. Theoretical particles. This is where I start to get lost.
No worries. It's complex stuff. But basically, many of the theories that try to explain the matter-antimatter imbalance, they rely on these hypothetical particles that we've never actually seen.
Like what?
Things like inflatons, thought to be responsible for the rapid expansion of the universe in the first fraction of a second after the Big Bang. And then there are right-handed neutrinos. We only know about left-handed neutrinos, but some theories predict their right-handed counterparts must exist to explain CP violation.
So we're basing all this on things we don't even know for sure exist yet. Sounds a bit like building a house of cards, doesn't it?
There's definitely a lot of uncertainty. But that's part of what makes science exciting. We're pushing the boundaries of what we know, exploring the unknown.
You're right. It's pretty amazing to think about, but it also makes you realize just how much we don't know.
Absolutely. And it takes us beyond just physics, too.
Yeah.
Well, even if DUNE finds the CP violation and gives us a clear mechanism for why there's more matter than antimatter, it still doesn't really answer the fundamental question.
Which is,
Why is there something rather than nothing? Like, where did the energy for the Big Bang come from? Why are there laws of physics at all?
whoa. Okay, so we're getting into some pretty heavy philosophical territory here. It's like we're trying to explain the existence of the universe, but maybe that's a question science can't answer on its own.
It's a question that humans have been grappling with for millennia, and it might be that there is no single answer. Maybe it's a combination of science, philosophy, even spirituality.
It makes you wonder if the search for why is just as important as the search for how.
I think so. Ultimately, we're all trying to understand our place in this vast and mysterious universe.
And maybe that's the real takeaway from this whole deep dive.
I'd agree with that.
DUNE is this amazing feat of science and engineering. It might give us some incredible insights into neutrinos, the early universe, even the building blocks of reality. But the question of why, that might be something we each have to explore for ourselves.
I think that's a great way to put it.
Well, thanks for joining us for this incredibly thought-provoking deep dive. It's definitely given us a lot to ponder.
My pleasure.
To all you listeners out there, thanks for tuning in. We'll catch you next time for another deep dive into the mysteries of the universe. And until then, keep looking up and keep asking those big questions. Because who knows, maybe the answer is out there waiting to be discovered.